Okay, logarithmic functions. Alright, this is a bit out of order, but I wanted to record this because this is kind of hard to remember. Okay, let's just read this. In this tutorial, we will be looking at logarithmic functions. If you understand that a log is another way to write an exponent, it will help you tremendously when you work through various types of log problems. A log is another way to write an exponent. A log is another way to write an exponent. A log is another way to write an exponent. Okay. Tremendous various log problems. Alright, one thing that I will guide you through on this page is the definition of logs. Definition of logs, definition of logs, definition of logs. This is an important concept to have down. If you don't have it down, it makes it hard to work through log related problems. I will also take you through graphing, evaluating, and finding the domains of logs. I think you are ready to get started. Alright, graphing, evaluating, evaluating and finding the domain of logs, and finding the domain of logs, and finding the domain of logs. I said that in a complicated way. Evaluating and finding the domain of logs. Alright, anyway. Definition of log function. The logarithmic function with base b. Hold up. How do you pause this? Alright, I'll just call it logarithmic. Alright. The logarithmic function with base b, where b is greater than 0 and b cannot equal 0, is denoted by log b, and is defined by y equals log b x if and only if by equals x. Alright, base b. Alright, where b has to be bigger than 0, and b cannot be 1, b cannot be 1. Alright, so it's a function, it's going to have base b, and it's going to be greater than 0, and it can't be 1. So 1 and above, and denoted by log base b. When it's under, that means it's like base. I think a base can also be on the side, and it could be a big number, but well, just for now, just say log b, and is defined by y equals log bx. Actually, let's say base. Y equals log base x. Automatically, when you think base, sometimes you can just automatically think like the opposite of exponent, like it's down, and sometimes the base can be like a big number, so it's not like a under exponent, but automatically would be. Sometimes it's helpful to just think it's automatically going to go down. But anyway, log b x, if and only if b y equals x. So basically, base becomes this regular b. Small base becomes regular b. Small base becomes regular b. And y becomes exponent. Y becomes exponent. And this x right here at the end becomes equals x. X right here at the end becomes equals x. X right here at the end becomes equals x. So bam. B becomes regular b. Y becomes the exponent. And this x at the end becomes equals x. And this is like a thing that's hard to memorize. I've looked at other formulas. It's literally just hard to memorize. You literally just gotta go through this over and over until you memorize it. Some things you could just easily memorize, but this particular one is kind of hard to memorize. Alright, let me look at something real quick. Alright, in other words, and I cannot stress this enough, a log is another way to write an exponent. The definition can work in both directions. In some cases, you will have an equation written in log form and need to convert it to exponential form, and vice versa. So when you are converting from log form to exponential form, b is your base, y is your exponent, and x is what your exponential expression is set to. Note that your domain, all positive real numbers, and range is all real numbers. Alright, can't think of a way to explain that, but anyway. Log, another way to write an exponent. Log, another way to write an exponent. Log, another way to write an exponent. So you can work in both directions. It can become the exponent or the base. Exponent or base. And I'm going to continue this in the next video. Oh, they changed.